Bismillahirrahmanirrahim. My name is Muhammad Numan. In this tutorial, I will explain an easiest and quickest method of solving beams with movement distribution method. I will perform this method using MS Excel. I will solve a question from structure analysis book by R.C. Hibbeler, and in end we will compare our results. So let's proceed towards our question 7498. This is our question. Determine the internal moment at each support of the beam. As shown in figure, the moment of inertia of each span is indicated. Okay, I've already copied this problem to an Excel sheet, which is this one. So first of all, we have joints. We will specify joints in here. So we have three joints. It should B, C, and D. So write them here. B space C, then space D. Okay, now after that we have members. So we'll remember, we can see that we don't need member AB because it's a cantilever member. So we'll start from here, BA. Now BC and CB and CD and DC. Okay. Now we are already given I values, IAB, IBA, which are 500. For BC it's 750. For CB it's similarly 750. For CD it's 600. For DC it's also 600. Now lengths are 10 feet, 20 feet, 20 feet, and 15 feet, 15 feet. Now our next step is K. K is actually stiffness, and its formula for this condition will be 4EI by L. But we know that 4E is constant for all of the members, so we'll just take I by L, which will be equal to sign I divide sign by L. Enter. And now we'll drag it to all. So these are all our stiffnesses of this question. Now we'll proceed towards distribution factors. Distribution factor for here it will be 0 because it's the last endpoint, and we'll consider actually from point BA is actually a cantilever, so no movement is distributed, so distribution factor in this case will be always 0. And we'll start our question from this one. We'll consider that BA does not exist in distribution factors. So hinge as we know, in we have I don't hinge is actually 1. For hinge distribution factor we always take 1, and for fixed support we take distribution factor as 0. So here we'll write as 1, and for fixed support, which is DC, it will be 0. Okay, now here distribution factor of CB and CD. So what we will do is actually equal to 37.5 divided by sum of these two, and enter. Now similarly for this one, equal to, we take this distribution factor on same joint, that is C. So actually this distribution is its distribution from this member and this member to this joint. So we add stiffnesses of both two, equal to 40 divided by sum of 37.5 and 40, bracket close, enter. So these are our distribution factors. Now we comes to fixed and moments. So for fixed and moments, uh, we can see at this member 400 pounds load is applied at a distance of 10 feet from joint B. So simply it's 400 into 10, that is 4000, equal to 400 into length is 10, enter 4000. Now coming towards member BC and CB, on which 60 pounds per feet load is applied uniformly distributed. So here the main thing is sign convention. We take negative sign for the member BC because when load is applied, this will try to rotate it into clockwise direction. So for clockwise, we assume it as negative, and for anti-clockwise direction, we will assume it as positive. So we'll start our member BC with negative sign, and our formula is WL square by 12. So W is equal to 60 into L square. Here L is 20 feet raised to power 2, which is sine of square, and divided by 12. So we get minus 2000, and here it will be negative of this one, negative of this one, it will be 2000. Now member C and D, there is no load on member C, no member CD or member DC, so we put it as 0 and 0. Now coming towards release, release is 0 here at member BC and CB. It will be you must remember that release will always have a negative sign. So it is negative of sum of this one. Sorry, I have sum of these two into its distribution factor. In this sheet, always remember to fix distribution factor by pressing F4. With F4, two dollar signs are appeared. This means that this place is fixed. This distribution factor is fixed. Press enter. Now for this one, with member CB and CD, taking joint C equal to negative sum of these two into its distribution factor of CB, and fix it by pressing F4. Enter. Similarly here, equal to negative sum of these two into distribution factor, and F4 fix it. Now here equal to negative of this into this one, F4, enter. Now carry or movement, we have to carry these movements to each in each member, so no carry over required for this one. Put it 0. Now BC and CB equal to this divided by 2 and equal to BC divided by 2. Here equal to DC divided by 2 and equal to CD by 2. Enter. Now copy this, release and carry your movement. Control C, which means copy, and now press Control V, which means paste. Now keep on pasting it until we get 0 in all our results, 0 or 0.00. Control V, Control V, Control V, Control V. We are almost there. Now we have double zeros in each of our figure. So now do one thing, equal to sum of all these results up to fix and movements. Bracket close and enter. This will be your result. Now drag it like this. Okay, these are our results. Copy these members. make some borders so that these look different, and also color it some light color. Now we'll check our results with results of example in book. So example, coming down. Okay, these are results. 4000 minus 4000, 587 minus 587, and 293. Result are 4000 minus 4000, 587 minus 587, and minus 293. So our results are correct, and thank you for watching. I'll close this.